Hey y'all, Miss Brown here, your 8th grade science teacher. Okay, y'all, I'm going to do a twofer. I'm going to do my Wednesday, Thursday video together. So let me move my evil twin. Here we go. Okay, y'all. So let me get onto Canvas. So that way I can show y'all what we're doing. And then I'll do a video for Friday as well. So Wednesday, September 23rd, and Thursday, September 24th is what we're going to do today. So how's y'all's week going? It's a little slower, I feel like, even though y'all had Monday off, we were here. So I feel like it's a 4-day week for you guys, but not for us. Okay, perfect. So Wednesday, we started our brand new unit. So we're starting chemistry. So we started Unit 2, Topic 1, which is atomic structure. And then Topic 2 is chemical reactions, and Topic 3 is periodic table. And then our next unit is also chemistry as well. So Wednesday, September 23rd, click on essential question. So I always like to start by going over the essential question. We always rephrase it, and we always add it to our trusty, dusty Unit 2 science journal. So if you didn't come pick it up, make sure you pick it up because we are using it. So it says, write the essential question at the top, and then write the rephrased essential question at the bottom. And y'all are going to rephrase the words that are underlined. So rephrase characteristics, location, charge, like plus or minus, and then mass. So original essential question on the top, rephrase essential question on the bottom. Awesome. So then moving on to the next part. So what we did was y'all went through this atomic structure PBS learning interactive site. I love this site from Chem, thank y'all, such a nerd, but it is perfect. And it really walks you through and kind of introduces you to atoms, atomic structure. And then you need to follow along in Canvas. So it says your journal will be used, and you're going to work on page 2 of your journal. Sorry, y'all, my nose. So we did page 1. And then what you're going to do is you are going to go through the interactive site, and then you are going to answer the concept map on page, sorry, I'm trying to show you, on page 2. So you're going to use these words in the word bank, and you're going to try to organize it. There is a correct answer. So I suggested to have my kids work through the interactive site, which I'll show you in a second first. And then if you're still struggling, answer these discussion questions right over here. And then that should give you enough information to do the concept map or the bubble map. So hit the blue highlight, and it will pull you out to a new site. And then y'all are going to work through this site independently, take notes. So my kiddos in class took notes around kind of the margin as they were doing this interactive site. And then when they were done, did the discussion questions and then tried the concept map. So all you do is hit launch, y'all. And I'm not going to go through this step by step, but y'all are going to go through it on your own. And you hit launch, and you literally just go through the interactive site, and it will ask you questions. You'll type in some answers, has a couple interactive things that y'all will play with as you are going through the site. And then just take notes as you're going through. Doesn't necessarily need to be focus notes. It could be whatever notes that you want to kind of take. Could just be something quick and easy. So y'all, we'll see if this ever loads. I got a lot of tabs open. I have like 2 other windows with just as many tabs too. So Nerd Island Studios, sounds like the place I want to be, y'all. Nerd Island, I love it. So chemistry is all about how atoms behave and interact with each other. In order to understand why different kinds of atoms behave the way they do, we'll have to know something about how these atoms are put together. In this tutorial, we'll take a look at the parts of an atom and learn about properties of the atom's pieces. So notice how there's 26 pages. So I'm going to go through the first few, and then y'all can go through the rest on your own. So click on the tip of the pencil to begin our tour of the atom. So during this tour of the atom, pay close attention to the properties of the particles found inside. So everything living and non-living has atoms inside of it. Magnifying to the atomic level, let us see that the carbon atoms are vibrating in place. This is how we would expect the atoms in a solid to move. So they move real slow, they vibrate, versus a liquid moves more, versus gas, like y'all after lunch, moving quickly and rapidly. So each individual atom is spherical, which means a circle, a sphere, the 3D. And they're all fuzzy. The edges are fuzzy. So there doesn't seem to be a distinct beginning or end point. So let's take an even closer look at what's inside. So here it is, y'all, little atom. So in the center you have, I said I wasn't going to go through it, y'all, but I'm just going to go through it. So in the center you have protons and neutrons, and then the electrons orbit around the outside edge. So once we stop all the motion inside an atom, we see that it's made up of 3 types of particles. So let's take a look individually. So the first particle we look at is the proton. Protons are found in the center of the atom called the nucleus. So the nucleus is kind of like the brain of the atom. And it consists of protons, which are the blue ones, and something else. So it is the number of protons that will determine what the element of the atom is. So this atom has 6 protons, just like every other carbon atom. So carbon's atomic number is 6 because it has 6 protons. So if you count the blue dots, there's 6 of them are spheres, which means that there's 6 protons in a carbon atom. So let's find out what else is in the nucleus. So the number of protons is called the atomic number. It can be found for any element by looking at the periodic table. So here's the periodic table and here's your periodic square. So the atomic number is usually at the top, but some periodic tables have it at the bottom, and they have this number, which is the atomic mass, up top. But the atomic number, y'all, is always a single digit number, no decimals, no decimal point numbers, nothing, just a solid 1, 2, 3, 4, 5, 6, all the way up to like the 200s plus. So carbon's atomic number is 6. Why? Because it has 6 protons. So the atomic number tells you the number of protons in the atom. So protons have a mass of about 1 AMU, which is atomic mass unit. And y'all, every time I hear this now, I think of Descendants. Remember when Evie was doing the problem on the board and she called it AMU? And then the teacher's like looking at her. It's because it's AMU. So he knew something was up when she pronounced it AMU. So protons have a mass of about 1 atomic mass unit. So the actual mass is not really important, but you should remember that protons are one of the heavier pieces of the atom. So protons, and this is going to come in handy in Thursday's lesson, protons have an equal mass to one of the other particles. And then the third particle is very, very light. So all protons have a positive 1 charge. They wouldn't be able to stick together in the nucleus if it weren't for this next particle. So since protons all are positive, like charges repel. I'm sure y'all have heard of the term opposites attract. Positive and negative sides attract. Positive and negative side of a magnet. If you have 2 positive sides or 2 north poles, it's going to repel. So what they're saying is there has to be some other like particle inside the nucleus of the atom for it to be able to stick together. So we're going to take a look at what that is. So neutrons, or the red ones, are the other type of particle that can be found in the center of the nucleus. So what I remember is protons are positive, and neutrons are neutral. So you can even see it's the same exact wording, the same exact beginning. So neutrons are neutral, which means they don't have a charge. It's 0. They're not positive and they're not negative. And then I remember protons, the blue one, protons are positive. So y'all say that with me. Protons are positive and neutrons are neutral. So say that and it will help you remember. And both of these, y'all, can be found in the nucleus. So the neutrons are neutral and they're found in the nucleus. So neutrons don't have any charge, though the forces, through forces other than charge attractions, they're able to hold protons together in the nucleus. So protons and neutrons can kind of stick together in the nucleus of the atom. So neutrons have about the same mass as protons, making them major contributors to the mass of the atom. So neutrons are about 1 AMU, atomic mass unit. Protons are about 1. So on a balance, they'd be even. Protons and neutrons would be the same mass. They're both about 1 atomic mass unit. So the nucleus is the main part of the mass. That's like kind of like the heavy part of the mass. So the last type of particle is the electron, and electrons are the smallest of the three particles, which add virtually nothing to the mass of the atom, y'all. So on a scale, protons and neutrons would be heavier, and electrons would be very light. So it'd be like a 1 or 2 year old on a seesaw, and then the parent or the guardian on the other side causes it to go up. It's about like almost 2,000 electrons to the mass of one proton or one neutron. I believe like 1836 or something like that. So about 2,000 electrons equals the mass of one proton or one neutron. So like they said, electrons basically are nothing. It's like almost close to zero. Okay, so it should be noted that the atom pictured on the left is not drawn to scale. So given the size of the nucleus, the electrons would most likely be found over a quarter mile away. So we're showing you the nucleus is here and the electrons right there, but truthfully, it'd be the nucleus and like a quarter of a mile and then the electron. So atoms are mostly empty space, y'all. The nucleus is tightly packed with the protons and neutrons, and then the electrons are in what we call an electron cloud, kind of scattered around. There's a very kind of specific way, but there's a lot of empty space, y'all. So if you think about it, you could think about like a tennis ball at the center of a football field on the 50-yard line, and the first electron would be like a football field and a half away. So like a half a football field, a half a football field, and then another football field, and like that would be where the first electron is. So it's mostly empty space. So electrons give the atom that fuzzy edge that we mentioned earlier. They're always in constant motion in a space around the nucleus. Because they're always moving, there's no kind of distinct surface of an atom. So you can't like pin down the size of an atom because you have the nucleus that stays still with the protons and the neutrons. Neutrons are in the nucleus and they're neutral, and protons are positive and they're in the nucleus. And then you have electrons kind of sporadically spread out. So another analogy that you can think of is like, let's say people. You have like 5 or 6 people kind of huddled at the center, and then you have people just kind of randomly, kind of sporadically throughout the rest of the town. And all the empty space, all the roads, all the houses is all just empty space, which is empty. Like there's no stuff. So when they say, where is the mass of the atom? It's in the nucleus with the protons and the neutrons, because they're about 1 atomic mass unit. Electrons virtually weigh nothing, and it's mostly empty space. Okay, so electrons have a -1 charge and at times can move from one atom to another and be shared. So we're going to talk about what an ion is. And an ion, I-O-N, is when you have gain and loss of electrons. And then we'll talk later on about isotopes, which is gain and loss of neutrons. The protons never change, y'all. It's like a fingerprint. If it has 6 protons, it's carbon. If it has 1 proton, it's hydrogen. If it has 3 protons, it's lithium. It does not change. The only things that change are the electrons, and it's called an ion, or the isotope, the neutron, which is called an isotope. So electrons are negative, protons are positive, and neutrons are neutral. And like I said, electron amount can change, neutron amount can change, but the protons never change. It's like the fingerprint. It's called the identity of the element. So if you're looking at the periodic table, the atomic number is the number of protons. And if you change the number of protons, you change the atomic number. And if you change the atomic number, you change the element, y'all. So those always stay the same. So if an atom is neutral, it will have the same number of electrons as it does protons. What charges electrons? Negative. And what charges protons? Protons are positive. So if you have 2 plus and you have 2 minus, equals out to 0, which means that it's neutral. You can have 1 trillion neutrons and it's not going to affect the charge. Why? Because neutrons are neutral. So it doesn't matter if you have 2 plus and 2 minus equals 0, and you could have a bazillion trillion neutrons and it's not going to affect any charge. My face is starting to itch when I'm filming. It's so bizarre. So here's another thing that I noticed. Why are the protons so much bigger than the electrons? Remember? Because protons and neutrons have 1 atomic mass unit, and an electron is like 1/2000th of the mass of a proton. So electrons are very small comparatively. So you'll spend a lot of time learning about electrons because they're responsible for many properties of individual atoms, and they're involved in chemical reactions. So y'all, it's the moving, the electricity, that movement of those electrons that is causing that energy gain and energy loss, which is causing those chemical reactions. So let's see what you've learned, what's true about a proton. So y'all are going to go through and you are going to move these to try to, it's stuck. So you're going to move these to try to figure out if you're right or wrong. So what's the charge of a proton? What's the mass of a proton? Where are they located? And what's its role in the atom? And I'm not going to do it, y'all. I think I have to in order to move on. Okay, so let's do it together. So protons are positive. They're very heavy. They are located in the nucleus with the neutrons, and the role determines the identity of the atom. Remember, it's like the fingerprint. Then neutrons. Remember, neutrons are also in the nucleus. They help hold the atom together because that neutral charge with the positive proton helps it stick together. It is located in the nucleus because remember, neutrons are in the nucleus. Remember, the charge is 0 because neutrons are neutral. And then the mass is also heavy because protons and neutrons have the same mass. And then we'll do electrons. So remember, if protons are positive and neutrons are neutral, then electrons are negative. Remember, the mass is virtually 0 because it's like 1/2000th. So 2,000 electrons equals 1 proton. They are located outside of the nucleus in what we call the electron cloud. And it's responsible for reactivity, y'all, because the gain and loss of electrons creates those kind of energy transfers. So as you continue to study chemistry, you'll learn more about each of the 3 subatomic particles. What are subatomic particles? Remember, we talked about this in class. Sub, like submarine, means below. Sub, below, marine, water. Submarines go below water. Subterrane, what does terrain mean? Terrain means land. So subterranean creatures are creatures that live under the land. What about sub-zero temperatures? Sub, below, 0, 0, below 0 temperatures. So subatomic means inside, below the atom. And a particle is a part or a piece. So subatomic particles are the pieces inside of an atom, which are protons, neutrons, and electrons. So what you've learned here should give you the background information that you need to understand how the number and arrangement of each of these particles play a role in determining how the atoms will behave. So to review, protons are the identity. They're positive, and it is the atomic number. Carbon is atomic number 6 because it has 6 protons. Protons and electrons in a neutral atom are always equal. So if carbon has 6 protons, it also has 6 electrons. Electrons are negative, and they are located outside in the electron cloud. They orbit, they spin, they move so fast, and it's a lot of empty space. Protons are in the nucleus with the neutrons. Protons are positive, and neutrons are neutral, which means 0. So the neutron and the proton stick together in the nucleus or the brain of the atom, contain most of the mass because protons and neutrons have 1 mass each, so they're equal. And then electrons orbit around the outside edge, very close to 0 mass, and they are responsible for the reactivity of the element or the atom. Return to home page. So that's it, y'all. Let me hop back to, move my evil twin, hop back to my Canvas page. So you're going to try to complete this graphic organizer. My hint is that this is atom, and then you're going to use the word electron, electron cloud, negative charge, neutral charge, neutron, nucleus, positive charge, and proton to figure out how these kind of split up. So atom, and then you need to think, what could the split be? What determines like the main difference? The location maybe? So maybe these are split up by location. And then when you're done, y'all, you take pictures and you always upload it into your never-ending slideshow. So the homework is those discussion questions at the bottom. So you're going to finish up those discussion questions at the bottom. And then you're going to add that picture to your slideshow. When you're done, type something like, done, Miss Brown, you're the best science teacher in the world. I love you so much. Or you could be lame and just type done. But I love sweet notes. So tell me something good and tell me you're done so I can look at your journal. Okay, y'all, I think I'm actually going to stop this video and I'm just going to come right back on and do another video, but just so that way I have separate posts for my channel. So see y'all later. Love each and every one of you. And you fill my bucket every day. Overflowing. Bye, y'all.